Hi everyone. My name is Rob Canzaneri, and I'd like to welcome everyone to the Data Architecture Virtual Chapter. Today I have Jes, and she's going to give a topic with Azure and SQL Server, which we're really excited about hearing. And if y'all have any questions, it's recorded. You can email me at rob@SQLtigers, and I'll be glad to get the questions to Jes or myself, and we'll just help y'all out any way we can. Whoops, there we go. So if you're going to Pass Summit this year, please use this code. It's a discount code. It'll save you some money, and if enough people use it, we can give away a session. Not a session, we can give away a conference to someone. So it'd be kind of cool to give away. We were able to do it last year. Maybe we'll get to do it this year. So every year they give away a Passion Award, and if you know someone, please nominate them. I mean, if they're helping in the community or anything, just nominate them because I'm sure PASS would appreciate getting some candidates, and they'll evaluate it and pick out a great person. So finally, I'm going to talk about the upcoming SQL Saturday in Baton Rouge. I'm going to be talking on optimizing backups, and I'm really going to be focusing on how I took a specific backup problem that was running in 280 minutes, and I got it down to 17 minutes to run this backup. So there's a lot of tips and techniques. If you're there, come and see me. It would be great to say hi. So I want to talk really quick about, we have a sponsor today. We just got this sponsor. It's Nutanix, and Mike has joined us. Mike, are you online? I hope Mike's there. Mike, are you there?
Hey Rob, I'm here.
Okay, and I'm going to switch over to Mike, and he's going to talk about this great new sponsorship with the Data Architecture Chapter and Nutanix. Thank you, Mike.
No, thanks, Rob. I appreciate it.
So we should see your screen, hopefully.
All right, I just selected it over. Can you guys see it okay?
I can see it fine, thank you.
Okay, great. So I'll keep this short and sweet. I know everyone joined to hear about Azure and SQL Server, and obviously the cloud is top of mind to a lot of people. So my name is Mike McGee. I work in the tech marketing department with Nutanix, and a big part of what we do is around infrastructure at the end of the day, and specifically around what you might have heard called hyperconvergent infrastructure, and a big key to that is to really operate like a lot of the cloud properties of the world already operate. So we were actually founded by engineers from Google who wanted to take the benefits of the way that they've combined infrastructure within their data centers and bring that to on-premises deployments. So obviously, I don't have to tell you if you're joining an Azure and SQL Server, past conference that the movement to cloud, whether that be moving applications directly to the cloud, re-platforming to the cloud, or even just looking at hybrid opportunities is well underway. And there's a lot of key things driving that, and whether that be how quickly I can develop something for my company, so time to market, what's my OpEx and to using this solution, and that really comes down to how can I fractionally consume IT, not having to buy everything up front and have a huge CapEx cost initially, but really pay as I consume what's needed. It needs to be self-service. It needs to be easy to use. It needs to be, what a lot of people like to say, one-click simplicity. If you're a DBA and you want to get access to start writing code, you want that to be as easy as possible. So whether you're looking at something as a platform as a service that's already running SQL that you have access to, whether it's infrastructure as a service to move your SQL Server instances to, those are key things that we really need to make easy to use and consume. And another big thing about the cloud model is that it's continuously evolving and continuously adding features and adding innovation. And so whether that's, a lot of the features that you see added within SQL 2014 that integrate with Azure, whether that's, your always-on availability group in Azure as a secondary, whether that's backup to Azure, whether that's migrating databases to Azure. And if you even look at something like SQL 2016 with stretch databases and essentially doing an archive, if you will, of cold data to Azure, you really need to introduce those features and enable hybrid cloud, if you will, in a continuous fashion. So being software defined is really key to being able to do that. So with Nutanix, what we're trying to do, and I think we've really delivered on this, is take those benefits of the public cloud and make it something on-prem that you can not only run from a fractional consumption, a cost point of view, and ease of use, but also give you the control that you need. So whether that's specific SLAs around performance, whether that's data governance, how much of your data you need to archive and maintain on-prem. But I think you get the idea. So really giving the benefit of public cloud, but also the control of a private cloud, or really just an on-prem data center. So Nutanix helps to enable that by collapsing the infrastructure to making it more simple. And this is really what a lot of the cloud properties like Azure, like Google, like Facebook, et cetera, have done. And that's take what would generally be what people would call a three-tier architecture, where you have servers, a storage area network, and then separate storage technology, and combining that into one solution. And this is where the term hyperconverged comes from. So you really take these different layers and make them really not needed at the end of the day. So that's integrating the storage, the compute, and the hypervisor, which is key. Nutanix is a virtualization platform. So whether you're looking to run ESX, Hyper-V, or KVM, and Nutanix actually has our own variant of KVM, our own hypervisor that we call AHV, you'll have the choice and flexibility to run that on top of the platform. So hyperconvergence to us is really not only a combination of simplifying the hardware infrastructure, but also the day-to-day operations, whether that's initial deployment, scaling the solution by adding incrementally a single node at a time, upgrading, whether that's upgrading the server, updating the virtualization layer, updating the storage layer, updating the hardware, making that really easy to do and consume, and as one click and simple as possible, again, to really match what you're doing within the cloud today. We do that, again, based on virtualization. So our platform is going to be running a hypervisor of some form, like I said, ESX, Hyper-V, or AHV. Within that, we run a virtual storage controller, and that virtual storage controller combines not only the storage features that we offer, but also management, the ease of upgrade and all the other benefits that we have within the platform. So obviously, if you want the benefits of an on-premises solution, you need to bring a lot of the functionality that you would typically get out of existing storage architecture. So whether you're looking at things like snapshots or clones, data reduction technologies like compression, like deduplication, or even erasure coding, which is with it's really a form of RAID 5, RAID 6 to allow you to have more efficiency at the storage layer. So Nutanix brings that all into play, but by taking the internal resources to each server within a cluster, we started as small as 3-node clusters, and combining that into one storage pool. And we like to call it a distributed storage fabric. And it's literally one pool. The vast majority of our customers will do one large pool, whether that be 3 nodes, 16, 32, or even more. We have customers over 32 node deployments in single clusters, and customers that have over 1,600 nodes plus. So it's a highly scalable solution to be able to use it, and you're essentially removing the need of a storage area network. And one of the key features that we focus on, and it's really unique to the Nutanix platform, is something called locality, or data locality. And that's where we localize the operations for a given virtual machine to the storage resources local to the node on which it runs. Now that isn't a hard requirement. We can obviously access storage anywhere from in the cluster, and if you think of doing live migration and moving VMs around, you need that kind of flexibility. But at the same time, if we can, if you do a read operation or a write operation, we'll write locally first before we write remotely, or in parallel as we write remotely. And if you do a read operation, we'll avoid traversing the network by trying to retrieve that data locally within the server. So if you think about localized SSD resources, or if you think down the road using things like NVMe or 3D XPoint or some of the other NAND technology that's coming out with respect to flash, eliminating the need to traverse a network to access that data is only going to improve performance, especially if you're looking at things like SQL Server and high performance, whether that's your decision support systems, analytical processing, or even your OLTP type environment. So really, what we've seen as our platform has grown is all kinds of use cases coming down the pipe, especially with SQL Server. So we have customers doing their OLTP, the transaction processing, like I mentioned, analytical processing, decision support. So a lot of times, initially, customers will look at us as like, okay, maybe I'll move some of our reporting to Nutanix, and that expands into other use cases. So at the end of the day, you can really benefit with this kind of platform. Not only do you localize the I/O if needed to a given node, it also allows you to scale linearly as you grow, as you add nodes. And it also lets you consolidate. So you're not going to impact other workloads. We frequently have customers that will run their reporting instances of SQL in parallel with their production instances within the same cluster. and that's because we have that kind of pseudo isolation, if you will, based on data locality. And obviously, the performance on top of that is going to be great because we have SSD resources or even all-flash clusters if you so choose. And the cost of flash has come down so much that we're seeing a big uptick in all-flash clusters. So if you talk about great performance, whether it's random or throughput-based workloads, it's actually a great way to utilize our platform. But a lot of people, like when they first start with SQL Server on Nutanix, they kind of dip their toes, if you will. They're getting used to hyperconvergence. They might be moving from a more traditional three-tier architecture. So test and dev is another great example. So if you're obviously logging into this call, you might be a developer thinking about how you write code to Azure. It's also important, to have your own resources to be able to do tests. And so a great way to do that is through cloning of your actual production workload. So you can have access to that existing data without actually running against that production server. So the ability to create very fast clones that don't impact production and give you fast access to be able to test or write against your production data is very important. So we see a lot of customers do that on our platform as well. And lastly, again, like I mentioned, I didn't want to take a lot of time. It's more than just about running SQL Server on-prem. If you're looking at Azure or Azure consistent methodologies that you might run on premises, you might be talking about Azure Pack, which is a way to run some of the Azure services on-prem today. Or you could even be looking at Azure Stack, which is really the next evolution, where you're going to be truly taking the APIs that you'd otherwise use within Azure and be able to run that on-prem. It's not available yet, but needless to say, with our platform, we're working with Microsoft and partnering with Microsoft to help deliver these kinds of services that you can run on-prem. And that'll make it that much easier if you're looking at a hybrid cloud model, if you're writing code for SQL Server services that might be running within Azure, to also be able to run on-prem. So we're one of the few vendors that are part of the cloud platform system ecosystem. We have a cloud platform system standard offering that runs on Nutanix, and that's basically a bundled offering where you get Hyper-V, you get the Nutanix platform, and you also get the Azure Pack System Center, as well as Windows, pre-configured and essentially ready to run. So just another layer at which kind of eliminates the need to stand this up on your own and a lot of the complexity, and again, really helps to enable the hybrid cloud. If you'd like some additional resources, I think we can make these slides available after the fact, but please check out our SQL Server best practices to kind of give you an idea of the kinds of workloads and the kind of things you can do with our platform, but also some of the overview, whether that's getting to learn a little bit more about Nutanix, what we do at Nutanix.com, and also our CPS solution, or just Microsoft solutions in general, so Nutanix.com/Microsoft. So again, want to be respectful of your time, so I really appreciate letting us join today. And down the road, what we're planning on doing is having a session specific to hyperconvergence, where we really don't talk about we don't plan to talk about us in general, but really what are the considerations when you're looking at hyperconvergence, whether that be from a sizing perspective, scaling perspective, disaster recovery, backup, performance, and really what to consider if you're looking at us, if you're looking at other vendors. We try to kind of make it generic, not make it a pitch, but give you real actionable information on if you're considering moving from a three-tier architecture to hyperconvergence and what to consider. So we look forward to talking about that down the road.
Thank you, Mike.
No, thank you, Rob. And again, looking forward to talking with folks down the road. And if you want to ping me about anything, by all means, my Twitter handle is at MCGHEM, so it's McGee without the additional E, just replace it with an M, MCGHEM. And love to take this conversation offline.
Okay. And if y'all have questions, I can forward to Mike. I'll make sure he gets all the questions, and we'll make sure anything y'all have, questions or whatever, we'll get taken care of. And now we have Jes, who's going to be talking about Azure and SQL Server too. And what's really cool is Jes told me she's going to be speaking at Intersessions. So if you can't make Summit, and you try to get to Intersessions. That's an awesome event too this year. So, Jes. Uh-oh.
Yes, I'm ready. You should be.
Cool. I'm going to try. Oh, let's see if I can. Oh, it's working. Great. I didn't have to switch. That's amazing. Thank you. Thank you, Mike. You must have did that. So, if y'all have questions, just type them in, and we'll hold off till she's ready, and we'll kind of help Jes and and see what we can do. Thank you for coming on, Jes.
Yeah, no problem. Robert, just so I know, is this session being recorded so people can go back and watch later or pass it on to other people?
It is. We're recording the session, and it's a great question, and I'm going to put it on YouTube under the Data Architecture chapter. So I will have a link on our Data Architecture chapter at PASS. So, and if any issues, y'all can email me, Rob at SQL Tigers, and I'll make sure that I'll get you the link to this session.
All right, well, I'll go ahead and take it away then. So thank you, everyone, for taking some time out of your day to learn more about SQL Server in Azure and essentials primarily for database developers. My name is Jes Borland. I'm a senior SQL Server engineer at Concurrency, a Microsoft partner consulting firm. I'm a Microsoft Data Platform MVP, and for the last couple of years, I've been extensively working with clients to get them moved into Azure in a couple of different ways, which we'll talk about here during this presentation. I want you to be able to understand some of the things that you need to know about using SQL Server in Azure by the end of this session. I cover a lot of topics at a very high level. It feels like that's the only way to get into Azure. You have to start kind of small and build up. The good news is I've published a blog post which has further links for reading, Microsoft Virtual Academy classes, etc. And I'll have that blog post up at the end of the session, so stay tuned for that. So let's just get rolling. Let's talk about, first off, some basics for Azure. I'm going to assume that maybe you've dabbled in it a little bit. Maybe you have your own trial subscription. Maybe your company has one. But I really want to get you started on the foundational information. See, when we want to put a database into Azure, whether that's SQL Server or another type, or if someone wants to put even an application in Azure, there are several steps you have to take and consider before we ever actually start creating a database or start creating a server. A lot of those revolve around one skill I wish more people in IT focused on, and that is networking. So a couple of things that I want you to be able to understand about Azure before you start building things. Number one is, how do we, from our laptops or from our workstations or from the server in our data center that hosts an application, get connected to our servers and our databases in Azure? That's called our cross-premises connectivity. So there are some services in Azure in which we can, say, assign a public IP address and connect to it that way, but not all of them, and you don't always want that. So some other things that you, or more likely your networking admin cloud team, would do are things like set up a point-to-site or site-to-site VPN. Point-to-site is more of a client that's put on a laptop or a server. Site-to-site requires an actual VPN device. Once companies start getting into really using Azure, we're talking web applications, Azure Store, machine learning, CDN, anything like that, and they start really consuming a lot of data and have a lot of clients at their location on premises connecting into Azure, I start recommending that they look at an express route. Now, this is basically a private tunnel from an on-premises network into Azure, available from some service providers. It comes with more reliability, more speed, lower latency, higher security, and a bigger price tag. But it's an organizational-wide decision to get an express route, but something to keep in mind as you start building up your Azure resources. One of the best learning tools about Azure cross-premises connectivity is this video from Channel 9 on Azure Network Infrastructure. One of the links I recommend you read and start with. The next thing I want you to understand about Azure is networking inside of it. You know that your resources are isolated from the next company's resources, which are isolated from the other company's resources. But even within your own Azure subscription, even within your own company's information, we can segment it further. So imagine that once you connect into Azure, into your subscription, there's going to be one or more virtual networks. These virtual networks have their own addressing, their own gateways, and they're independent of each other. So when you're going to go ahead and be configuring servers, web servers, databases, etc., you really need to sit down and have a big overall reaching discussion with your architects, your networking people, your storage people to understand, okay, how many virtual networks are we going to have? What resources are going to be allowed inside of them? How are we going to subnet those out? I've made the mistake before while testing some things of not carefully considering which VNet I'm putting things in. That's a pain in the butt because you can't move things around later. Again, networking inside Azure is one of the most fundamental things to understand, even if you're not a network admin. So I highly recommend that you check out this Microsoft Virtual Academy course on Azure Networking Fundamentals for IT Professionals. Really great resource for learning more. All right, so once we're past the boring networking stuff, another thing you need to understand is what you're paying for. A lot of these costs in an on-premises data center kind of just get folded in, or they aren't really obvious, right? You're paying for power, you're paying for cooling, you're paying for real estate, you're paying for all of your storage. When you go into Azure, all of these costs are going to be independently broken out. So anything with your network, whether you set up a VPN gateway or an express route, is something the company is paying for. When you're setting up infrastructure as a service virtual machines, you're paying for the compute power and maybe your licensing. You're also paying for storage to attach to those VMs or to put backups on. When you're using platform as a service, you pay for the platform, whether that's SQL database throughput or Azure automation hours. And a big thing that developers need to understand is you pay for every byte of data that is egressed. So anything that needs to come out of Azure to go back to an application, to go back to a client, you're paying for that. One of my big things is when you go into Azure, it's not just that all bad queries are worth tuning, it's all queries are worth tuning. If you have very chatty applications that request the same data over and over again, you really need to think about implementing something like application caching or other tools to reduce the calls to the databases in Azure and bringing that back. Just understand that when you have Azure, you're paying for everything and it's broken out separately. And last thing to talk about before we get into the actual SQL stuff, which you're thinking, gosh, not a lot of stuff about SQL Server in this talk about SQL Server and Azure, Jess, is going to be managing. How do you manage your resources? How do you create them? How do you alter them? How do you stop them if you no longer need them? There are 3 things you're going to need to know. Number 1 is the classic portal. That's the manage.windowsazure.com. I don't use that very often, but because I want to say about 1.5 years, 2 years ago, they introduced the portal.azure.com, and it's Blade system. And it would be really great if we could manage all of the Azure features from one or the other. But Microsoft's not quite there yet. I wish they were. They're not. So there's this link to the Azure portal availability that'll tell you which services can be managed from which one. The good news, almost all data-related services are available on the portal. The only one that I know for sure is not is machine learning. That still needs to be accessed from the classic portal. And even better is going to be PowerShell. I like to think I adopted PowerShell early on. I was a fan, 6 years ago, and that was still not really early. But now I'm really glad I learned it. And I know that it's another language to learn, and I know that it's not a classic developer language, but PowerShell is absolutely essential for managing your Azure resources. There are a lot of commands in both the infrastructure and the platform models that can be kind of done with the portal, but really require PowerShell to do them powerfully. And all of the automation tools within Azure also rely on PowerShell. So what you'll need to do is download the PowerShell commandlets and install them. And there's a full reference out on MSDN. The other good thing is that when you go into the Azure documentation site, almost all of the articles now will show you how to do things using the GUI through the portal, using the PowerShell, and then use something like ARM, Azure Resource Manager. So you're going to have to know a little bit of PowerShell. All right. Enough with the administrata. Let's talk about SQL Server. So what options do we have? A lot. This is the Azure Periodic Table. This is a high-level view of the different categories of services within Azure. Data is only a fraction of those, and we're only going to talk about part of that. For example, my PowerPoint is having some issues. We're going to talk about using virtual machines, infrastructure as a service, to host SQL Server. And we are going to talk about using the SQL database platform. Other things you could talk about, the SQL data warehouse, which is an analysis, a massive parallel processing tool for in the cloud. We have Document DB, which is a NoSQL database. There's HD Insight for big data and Hadoop. So there are a lot of data services available in Azure. We're going to talk about just a couple of them. The most common is going to be IaaS, or infrastructure as a service. This is where we build a Windows Server virtual machine, and then we get SQL Server on it. And there's a couple of different ways you can do that. So BYOL, or bring your own licensing, is a very popular option. You select the Windows virtual machine size and build it. Then you upload your SQL Server installation media and install it and configure it. You basically are just paying, you're just paying the compute costs through Azure. You pay your SQL Server licensing, however you're doing that in your current agreement with Microsoft. The other option is to use an image. This is where you go into the portal and you go to virtual machines and you search for SQL Server and you configure a bunch of things about it, like the VM name, which virtual network it's on, what network security group it's in, what your admin account will be, do you want automated backups taken? And it takes longer to generate than just a Windows VM because all of the SQL Server features are being installed, right? You're going to get analysis services, reporting services, integration services, but once it's done, you're done. You just have to go through and configure it. In this case, then you're paying Microsoft for both the Windows compute costs and the SQL licensing costs. The newest option they give us is the BYOL image, where you pick an image and then you have to go through and within 10 days enter your licensing key or it'll stop working. Now, one thing to understand is that there is not truly a development or test tier within Azure. Right? We can't say, well, I'm just testing this stuff out, so don't charge me. What if you do want to move your development environment into Azure? How can you help contain the costs? The way I would recommend doing that is using the bring your own licensing or image, creating a Windows Server VM with a very small size, but you are going to be installing Developer Edition. So 2014 and 2016 are available on the portal with all of the usual restrictions about using Developer Edition. Another option that you have is using the Azure Dev Test Labs. This is an environment where you take users in your environment, put them into a group. They can only create resources in this group that are no larger than a certain VM size. And the resources are scheduled to come online at 8 a.m. and go offline at 4 p.m. So you only have charges 8 hours a day. There are some options for getting development in Azure. So just so you kind of understand how the pricing structure works, with the Windows Server compute costs, there are different tiers such as standard and optimized and different sizes within those tiers. Those things determine how many CPU cores you have, how much memory you have, what the local attached disk size is. And the other thing that it will determine is whether or not you can attach premium storage being SSD. Then if you choose to do an image, you're also paying SQL Server licensing, web, standard, or enterprise. This basically equates to number of cores you have. Enterprise edition, 2 cores, $1.50 an hour. Even on a higher level tier, 2 cores of enterprise, $1.50 an hour. Pricing changes frequently. This is not the permanent price of what it is right now. So that's infrastructure as a service. The other option that you have is the platform as a service SQL database. SQL database is a data store only for your relational data, which you can use the Transact SQL language to interact with. You have no control over your server level things. You don't get to set things like max and min memory. You don't get to build server level logins that are matched to one or more users in one or more databases. You don't get to set up things like SQL Server Agent. The good news is you don't have to worry about server level settings. You don't have to worry agent. You don't have to worry about backups, although you should be at least thinking about your backups. Understand that there's a couple different ways you can set up the databases. You can set up the elastic pool, which is one or more databases that share resources, or you can just set up one database at a time. But also understand that there are no other services, right? You won't be able to just create SSIS in Azure. You won't be able to just spin up SSRS databases in Azure. The rough equivalents are SQL Data Warehouse for OLAP or data warehousing, Azure Data Factory, which does much of the ETL similar to integration services, and both a reporting services, either on premises or in an Azure VM, can access a SQL database. The full cloud option is the Power BI service. So I am seeing a question in the Q&A about that Dev Test Labs, going back a slide or two. Yeah. The Azure Dev Test Labs, right? Can you do, is it from 8 a.m. to 4 p.m. every day, or can you change that schedule? You can absolutely change that schedule to be whatever you need. I just used that as an example. All right. So, so looking at what you get when pricing Azure databases, so again, you pick a tier. That tier determines how many DTUs you get. We'll talk about that later. The largest size a database in that can be, and then how much it is per month. And in a pool of databases, this determines how many total databases you can put in one pool, how large all of those databases can be, and what the maximum DTUs per database are. Notice the larger it gets, the more expensive it is. That's the way it rolls. So what are common reasons to use IaaS over PaaS, or to pick SQL database instead of just installing full-on instances of SQL Server? I find that IaaS is better when you're looking to take an existing application database, an existing workload, and move it into Azure. As I'll cover later, there are limitations around SQL database that may not work for taking an existing set and just moving it in. If your database is now or will be larger than 1 terabyte, go with a SQL Server virtual machine. There are hard limits on database sizes in SQL database. IaaS is also great as using disaster recovery for your on-premises SQL Server instances. I know that there have been many times when someone's had an always-on availability group on premises and they just want to extend that into the cloud. And we can easily add another VM to participate as like an async replica in that group. The SQL database works a lot better for new, fresh applications where you can easily work within the limitations of the service. It's especially well designed if you're building web apps. It's also great if you have an application database and you don't want to worry about high availability, you don't want to worry about backups, and you just want minimal setup for your DR. A lot of that is built into the service. It's also great if you have workloads that vary greatly. Say you have a system that's really, really busy during the holidays, and then it's really slow from March through June. In an IaaS, you're paying the same costs all the time. In PaaS, you could say, okay, well, I'm going to make this an S7 for 3 months, and I'm going to spit it down to an S2 the rest of the time and save myself money. The elastic database feature of SQL database is also really great for software as a service type models where you currently have a lot of single tenant databases, or maybe you have a multi-tenant architecture and you want to split it out into single tenant. These are just a few of the use cases, and obviously sometimes one can work well for the other. We're going to take a look now more in depth into each of these options. So starting with Windows and SQL Server virtual machines. Just to kind of understand the workflow of getting one of these set up, you determine if you're going to use the image or your own licensing. Build it and configure it. Install and configure SQL Server. Set up your maintenance and test connectivity. So just a couple of things that I really want to point out here. Just because you have a SQL Server virtual machine that you create from an image does not mean it is set up according to best practice for SQL Server. You should have a SQL Server post-installation checklist. You should be following that for all SQL Server installations, on-premises or in Azure. You do still need to set up maintenance. You absolutely need to be taking backups, scheduling check DBs, doing your index maintenance. There is nothing in Azure that will do that stuff for you. And again, my audience is primarily designed to be developers, but if you don't have a dedicated DBA who does these things, you need to be aware that you should be doing those things. Let's talk about that last one now, testing that connectivity. I've mentioned how important networking is. I'm going to mention it again. Networking is the single hardest part of working with Azure. You really do need to understand the fundamentals and have that set up correctly before you ever start using your application as a production system. So what you want to make sure of is that you can connect all of your applications and web servers or whatever else needs to access that database server to the database server. Now, if everything in your system is in Azure, it's really easy. If everything's in that same virtual network, you can just use a connection string with integrated security. If you're doing something where you're in a different VNet or in an on-premises install, you have to follow some more steps to make sure that you can connect. The good news is there is an article on connecting to a SQL Server virtual machine on Azure. Again, that's one of those links in the blog post that I'll be showing you the link for later. Now, what if you do have an existing database, an existing application, and you want to move that into Azure? How can you do that? I wish there was a super easy button. I wish there was some, magic script on the portal that you could just say, all right, here's my old database server and database name. Here's the new server and database name. Magically transport it all. Not quite that easy, unfortunately. Some ways that you can move data, though. You could take a backup on your old server and restore it into your SQL Server VM. You could create an SSIS package. You can move the schema. You can move the schema and data. That might be great if it's something you need to do on a regular basis. You can also use SQL Server's DAC packs. Those are essentially, I'm simplifying this greatly, a way to zip up the schema, zip up the data, and import them into another SQL Server instance. I want to point out how you move data into the database because it's something you definitely need to consider if you're moving an application into Azure. Another thing to understand is the ability to scale up and down within the Azure virtual machines. You can choose to use a larger instance sometimes and scale down to a smaller instance. The VM will stay online. It could take a couple of minutes. It could take significantly longer if you're going from a very small VM to a much larger VM, or vice versa. You can do it through the portal, or the way I prefer to do it is through a PowerShell script. The most important point of this is, people always think, gosh, if I just go into Windows Server, so say, especially if it's like a test environment, I'm just going to go into Windows Server, I'm going to hit Shutdown, it's going to shut down my VM, and then I'm not being charged. That is false. The only way to have a VM shut down and not be charged is if it says, if the status on the portal is stopped, deallocated. The only way to get that is to go into the portal, select your virtual machine, and hit the stop button at the top, or call the shutdown role operation command in PowerShell. So just understand that if your VM does not say stopped deallocated as the status, you are being charged. And understand that's only for the compute. If you had additional disks attached to it, you are still paying for that storage. If you have a public IP address set up for that VM, you are still being charged for it. And if you decide to set up multiple virtual machines, say you want to test an always-on availability group, you need to shut all of them down, or you will pay for the ones that are still running. So just keep that in mind so you can help manage your resources more effectively. Another question that I see is, are you still paying for the licensing when it's shut down and deallocated? And I'm assuming that that question is, am I paying for the SQL Server licensing? The answer is no. If you use an image and it is stopped deallocated, you are not paying for the compute and you are not paying for the SQL Server licensing for the hours it is shut down. Now, as a developer, what you're most interested in is what is supported. Good news, everything. It's basically, using an Azure VM for SQL Server is roughly the equivalent of just moving your SQL Server into another data center. Again, the biggest thing to think about is connectivity, networking, that sort of thing. If you have an existing application that uses CLR or has change data capture enabled or uses another Enterprise Edition feature, all fine and good, no problems with getting that to work. Now, when we're going to develop against those tools or against those databases, What tools do we need? Well, again, biggest thing, we need to be able to connect from our workstation into the Azure Virtual Machine. We can do that through SQL Server Management Studio or through Visual Studio. One note about SQL Server Management Studio. As of the last 6 months or so, and with the release of SQL Server 2016, Microsoft has decoupled the SQL Server Management Studio from the SQL Server installation media itself. You can now go out to the MSTN website, download a standalone SSMS, and it gets updated monthly. I highly recommend you use this. If you have not used Visual Studio but would like to, you can now download Visual Studio Community 2015 for free. Yes, free, and you can use that. That gives you some other, more developer-y tools like snap-ins to source control and, just that familiar Visual Studio interface. So again, with IaaS, with SQL Server Virtual Machines in Azure, the biggest pain points that I see from a development perspective: network. Can we access our resources? And also, is the size of the pipe that we have from the users to the application servers to the database and back big enough to support our current workload? Once that starts to become a bottleneck, that's when you need to start thinking about things like site-to-site VPNs or even the express route. You need to make sure that you can adequately meet performance expectations by having the right sized virtual machine and the appropriate storage. Again, we have premium storage, which runs SSD, that you may need to use for certain workloads. And security, is everything set up to allow the right users to access the right data? That's really no different than any other application going into a SQL Server database. So the transition from your on-premises SQL Server instances into an Azure SQL Server virtual machine should be relatively painless after you get over the networking stuff. Now let's talk about a whole new world when we talk about the Platform as a Service SQL database. First, when it comes to both pricing and performance, comparing the virtual machines to SQL database is like comparing apples to oranges. It's a different paradigm. You saw on that earlier slide where I had information about the Azure SQL database pricing. I mentioned DTUs, or database throughput units. In a virtual machine, the person who builds the virtual machine gets to specify how many CPUs they would like, how much memory they want, and what the size of the local disk is. And then by attaching other storage and properly striping it, rating it, creating storage pools in Windows, you can get more storage and determine its speed, etc. You don't have that with SQL database. You choose how many DTUs you want. The Microsoft definition of a DTU is how many transactions could be completed per second under fully loaded conditions. This combines your processing power, your memory, your reads, and your writes. I don't even know all the ins and outs of it myself by heart, but Microsoft has written an article on the SQL database benchmark overview that tells you how they've benchmarked each of the different tiers. I highly recommend a read if you're interested in more information on that. One thing to note is if you set it to, say, a level that has 50 DTUs, right? 50 transactions per second, and all of a sudden you get this huge spike in usage, you can see your transactions throttled. If your tier says 50 DTUs per second and you're trying to push through 1,000, it's going to slow down. You're not going to get all of them. You have to really keep an eye on how many DTUs you are using currently and over time. And there are tools in the portal that will show you that. You can get alerts on that through the portal. And this is where being able to scale up and scale down effectively comes into play. Now, I've already mentioned that SQL database is, at least for me, better if you have a new application or new server. If you do want to try to move an existing workload into a SQL database and you're trying to figure out how do I get that, how do I know how many DTUs to pick? There is a DTU calculator tool available from the Azure SQL database team that you can use. I've had some people say, it doesn't work that great. But I say, hey, it gives me somewhere to start, which is better than nothing. Now, the workflow when we're creating a SQL database. We choose our tier and create it. Now, you're not going to need to set backups. You're not going to need to set up high availability, but you will need to at least configure your DR. You need to configure your connectivity because you need to either specify that a specific IP address or a range of IP addresses can access that SQL database. So again, networking stuff, it's all over in Azure. And you also need to configure some of your maintenance. You are using an Azure SQL database. You still need to run DBCC check DB. You still need to do index and statistics maintenance. Well, maybe not you. Maybe you have a DBA that does that. I don't have time to go into, in this session, how to do that, but there are a couple of tools like Azure Automation that will allow you to do that. Now a big one. This is the question I always get. I probably get this question twice a week on Twitter. What are the differences between a SQL Server instance and a SQL database? As I've mentioned earlier, anything that's at the server level in SQL Server, setting your max step, setting your cost threshold for parallelism, configuring max and min memory settings, setting up server level logins, setting up SQL Server agent jobs, that's not available at all. Within the database itself, some commands are partially supported. That means things like create database, or procedure, or function, or table. Most of the commands through T-SQL work, but anything that would affect it at a server level or work with any server level options won't. The good news is I think the MSDN documentation on what's supported and what isn't is thorough. It is very clear. But then there's a whole bunch of other stuff that's not supported. Number one, cross-database queries. So if you have two Azure SQL databases, you cannot say select A, B, and C from database dot, server dot database dot schema dot table, unless you have both of the databases in an elastic pool and you use some polybase commands. So understand, if you have a series of related databases, or you plan to make a series of related databases, there's no native cross-database querying. This also means that we can't use things that are cross-server. You can't set up a linked server. You can't use an open query command. Server-level features that are not available: database mail and SQL Server agent. You have to use other tools to schedule jobs, schedule stored procedures running at a specific time, sending out results of a query. Replication is not supported, except if you have, I believe the rules are you can make it a it cannot be a publisher under any circumstances. With SQL Server 2016, I know it can be a subscriber. You cannot use features like CDC or data collector or file stream or service broker. You also cannot use profiler /trace to monitor your events. So again, these are a lot of reasons that I've seen people trying to move an existing database or an existing workload into a SQL database and not be successful. knowing the limitations ahead of time can prevent a lot of headaches farther down the road. And Microsoft, now this is not the definitive list, this changes. Microsoft is trying to make its product more, more closely aligned with SQL Server itself. It won't be able to do that with everything. So this SQL database, transact, SQL information link at the bottom is going to be where you want to go to get the latest and greatest. Now, if you have an existing application, how do you move data into the database? Again, not an easy button. You'll notice one big thing is missing here. We can't take a native SQL Server.bak and just restore it into a SQL database. We have to do something with ETL to get the data in, or again, use our DAC packs, our data tier applications, where we zip up the schema and or data. What tools can we use to develop against an Azure SQL database? Again, SQL Server Management Studio or Visual Studio. For SQL Server Management Studio, you absolutely want to get the standalone SSMS, and you definitely want to make sure that every month when it says an update is available, that you click on that little bubble that pops up on your desktop, you download it, and you keep it updated. Because frequently, if there are new features or new management tools available for your SQL database, they're going to be in that monthly update. Now, as I mentioned earlier, with a SQL Server in a VM, all of your tools are available for your regular performance tuning, for troubleshooting, for developing, for features. The tools that you will use, particularly for query performance, baselining, benchmarking, etc., have changed a little bit. I want to give you an idea of what options you have. First off, weight statistics. This is not just the realm of the DBA. I feel that developers should understand weight statistics as well. Weight statistics tell me when my database is running queries, what resources is it waiting on the majority of the time. Just helps you understand what might be a bottleneck. In SQL Server, we use the sys.dmos wait stats DMV. With SQL Database, we need to use the sys.dmdb wait stats. So notice OS has changed to DB. Azure documentation says it's stored since the database was created, moved, or taken offline. What I recommend you would do is use a tool, again, like Azure Automation or SQL Server Agent running on a virtual machine to regularly query that data, store it in another table, have it available for later reference for benchmarking. Weight statistics are going to tell you, again, where it hurts. Now, for more specific troubleshooting, to find out what queries were run in a given time period, or what locks have been taken, what deadlocks have occurred, you cannot use Profiler or Trace. Instead, we need to use extended events. I've been giving sessions on extended events for a couple of years, as have other presenters in the SQL Server community. Highly recommended that you learn the basics of them. Now, at a SQL Server level, particularly with SQL Server 2016, I think there are now, over 1,000 events exposed. For an Azure SQL database, the last time I did a count, there were 125. But once upon a time, when extended events were new in Azure SQL database, I was like, that's not enough. They must be missing something. and I emailed one of the program managers at Microsoft, and she replied back with, well, what else do you need? I spent a couple days running through scripts that I had with extended events, thinking about all of the possible things I would troubleshoot within a database, and I realized they really did cover all of the things. When you set up an extended event session, you have a couple different ways to view the data. For a really small session, viewing a small amount of data over a short period of time, you can do a memory-based target. For more information that you want stored for reference later, you can use a disk-based target. Now note that to use extended events, you do need to use SQL Server Management Studio to view them. That capability is not available, at least in Visual Studio Community 2015 edition that I'm aware of. Another thing to note is that to create the sessions or edit the sessions, to start them, to stop them, you have to use T-SQL. This is not something that there is a GUI for, even with SSMS. But again, extended events are a very powerful tool for tracing and real-time analysis. Now, what about more historical analysis? In a SQL Server, you're going to have the plan cache. That's going to store execution plans in memory. Note that that is exactly the same. My query that I use to search the plan cache in SQL Server works exactly the same in SQL Database. You can still view the XML execution plans. You can still save them and view the graphical version. Now, SQL Server 2016 introduced a new feature called Query Store. People are really excited about this. It's kind of this black box recorder for your queries. It shows historical data over time. Here's the thing that not a lot of people realize. That was in Azure for more than a year before it ever came into SQL Server 2016. Query Store is this, again, you set how much data you want to retain in terms of total size, number of plans, number of days, and it will keep track of how many times a query was executed with that plan, what CPU it used, what memory it used, how many times it was executed. This is really great for being able to keep track of historical data about a specific query or plan. It lets you get a lot of good information in terms of baselining and benchmarking. It also allows you to easily pull an outlier, right? Like 99% of the time this query runs great with this plan, but this one time, based on these parameters, the query was wildly different. Why? And there's another tool that's available in the portal called Query Performance Insight that works hand in hand with Query Store. So with Query Store, to view the data, you can use a lot of T-SQL, or you can use Query Performance Insight. So I see a few people, I know it is a little bit after the hour. I see a few people have dropped off. For those of you that can hang out with me for just a few more minutes, I think I have like 4 more slides. We're going a little bit over today just to allow our sponsor to start the meeting off. So that Query Performance Insight. This is a graphical tool available on the portal. Once you have Query Store enabled on your database, it allows you to say, okay, I'd like to view the top CPU consuming queries. I would like to view the top executed queries. And then you can select a query to view its details. The other thing that Query Performance Insight will generate, besides just maintaining these statistics about query execution and its numbers, are some recommendations for you. The recommendations are stored in what's called the SQL Database Advisor on the portal. The SQL Database Advisor is going to give you things like, here are indexes that I recommend, non-clustered indexes only. It will also try to detect duplicate indexes and give you drop index recommendations. For those of you that are thinking, gosh, This sounds very familiar. It does kind of remind me of the SQL Server database, what is that tool name? Now I can't even think of it. Yes, thank you, Neil. DTA, Database Tuning Advisory in SQL Server. It definitely proactively checks your workload, but be very careful about applying any recommended indexes. You need to make sure that they absolutely would be worthwhile, that they would not slow down any inserts, updates, deletes, and also that, you know, a very similar index does not already exist that could just be edited. Also be very careful about dropping indexes. You never know when that one you need may just be needed. There is an option in the SQL Database Advisor to just automate these options where you can say, yeah, if you find a create index statement, just go ahead and apply it. If I really had a wild hair, like I was going to go out, get my head shaved, get a few more piercings, I might turn that on a development box and just see what happens. There's probably not a chance in heck that I would do that on a production SQL database. So be very careful about turning on that little box. Database Advisor is also going to warn you of a few performance things. Or not necessarily performance things, but it's going to give you other warnings. For example, it will tell you if there are any schema issues. You know, if you're getting a lot of queries about queries that return invalid column name or invalid object name, invalid stored procedure. If there's just code that's outdated, someone doesn't understand the structure of the database, it was something old that was written and now the database has changed. And we need to have this information in the Database Advisor because we don't have a SQL Server error log for our SQL database to capture and view and be alerted on those errors. Also, it will notify you if there are queries that could benefit from parameterization. And if you click the box that says fix these, it just enables forced parameterization on your database. I don't know that I would want that turned on. I would probably first work to fix those queries. I would see if, is it parameter sniffing? Is it something that I could maybe rewrite my stored procedure a little bit to make it more efficient? Again, all of these things about automating within a database, you really have to understand how they work and how they're going to affect your system. But overall, I feel that Microsoft has built a good set of tools into Azure SQL Database to help you, baseline your system so you know what current usage is. I feel it gives you good tools for performance tuning and also some proactive tools to help you realize what could be done better. All right, so those are the very basics of developing applications for SQL Server in Azure. I highly recommend that if you have not yet given Azure a try, that you do. Almost every organization I talk to is considering Azure for, one thing or another. The modern database developer should be aware of what the benefits and the restrictions are, should know some of the limitations. So to get started, if you do have further questions, I'll take questions for just a couple of minutes, but I know that we are over our hour. Here is a link to the blog post that I created about this. It has links to all of the different resources that I have mentioned, and I'm going to try to put this in the chat window here. So you should see that if you have the chat window enabled for GoToMeeting, you should see that link there. You can also reach out to me via email or Twitter. I see a couple of other questions have come in via the Q&A. I'll have Robert get me the Q&A and send those on because there are a couple of questions that require some additional explanation. But are there any quick questions from anyone in the audience? All right.
Okay.
Uh,
Jes,
I would say
thank
if
you.
you have any questions, definitely reach out to me via email or Twitter. Check my blog post, leave comments there if you have further questions. And again, thanks for taking time out of your day to join me.
Jes, I just want to thank you for coming on today. It was great.
Thanks, Robert. Thanks for having me.
And it's and if you're going to intersessions, please check out our session. I mean,
Yeah. So at SQL Intersections, which is in Vegas at the end of October, I am giving a full day class on developing for Azure. I also have Azure Essentials for the database developer and Azure Essentials for the database administrator sessions throughout the week.
well, that sounds awesome. So thank everyone for coming today and spending a little over an hour with us, and thank our new sponsor. And we're going to have another meeting later in the month with someone from SQL Skills. And once again, thank y'all, and I look forward to everyone coming back next month. And it will be recorded, like I said, and I'll have the link up in the YouTube webinar hopefully by the end of the week. Y'all have a great evening. Thank you.